Hello, my name is Tulio,
My name is Abdullah.
Hi, I'm Ender Schmidt.
and our project today will be about predicting the prices of Bitcoin. So, as we all know, Bitcoin is very valuable in today's age, and the prices nowadays can reach over $60,000. So, with this project, our goal was to predict that price in order to find optimal times to purchase at minimum values as well as to sell at maximum values. And we decided to use two different models to predict this price. The first one being the long-term short memory or LSTM model combined with some RNN, and the second just the sole RNN model, where both of them use Keras and had a dense layer. And we determined the efficiency and accuracy of these models by testing hyperparameters and finding R squared score, maximum error, and explained variance. And for the features, we decided to use opening, closing, highest, lowest, as well as weighted Bitcoin price. And we decided not to use the Bitcoin volume or currency volume, given that they weren't really prices. And for the pre-processing, we removed all of the NAN values and converted the timestamp to dates. Then took means of the dates to get the training as well as the testing data. And the hyperparameters that were modified for the second model included batch size, testing data size, and layers of Keras.
So for the LCM model, we found one on Kaggle. And for this model, the size of the training and testing data sets did impact the overall score. We found out that larger training sets perform better than smaller ones, and that the model functions similarly for all given prices. The R squared values for this model were above 0.9 for 30 predicted test days. And by attempting to train more than one predicted value gives us an average instead of a true predicted price. And sometimes the model would not work correctly on training data and predicted a constant value. So this is our graph for the first model. As you can see, it's very accurate over the span of the year. And for our own implementation of the LSTM, we found out that it performed worse than the online version we found. And similarly, the model has almost the same functionality for all given prices. The R squared score and explained variance hover around 0.8 for 30 predicted test days or less. A weighted price yields best prediction because it resembles a median between the other Bitcoin prices, and a higher time step generally results in a less accurate model. As you can see, our model, it performs less accurate than the previous one, but it's still quite good. And this is the model by increasing the timestamp from 50 to 100. As you can see, it performs worse.
So for our RNN model, we discovered that with lower batch sizes, the scores were lower, but with higher batch sizes, they would almost match or surpass the original LSTM Kaggle version's predictions in terms of R squared score. We also attempted using extra RNN and dropout additions inspired by a Kaggle version of RNN, but we found that they decreased the R squared score. And finally, we discovered that the training set must be set for 65 to 90% in order for the model to work accurately. Otherwise, we would get false predictions and our R squared score would end up becoming negative or 0.2. So for our graph, it shows the 200 batch size, and as we can see, it's fairly accurate. But if we lower it to a 32 batch size, it becomes less accurate near the end. Here are all the sources that we used for this presentation. Thank you for watching this presentation. And if you have any questions, now is the time for our Q&A session. So feel free to ask away.